Well, hello everyone. This is Dr. Waite. Welcome to week 6. This week we are getting into the knee, the ankle, and the foot. For the chapter reading, we're in chapters 9 and 10 of the textbook. Um, there are two PowerPoints located on Blackboard under our week 6 content. So be sure to look through those. I'm going to do an overview of each of those, very brief overview of the knee joint, and a little bit about the ankle and foot as well. Then you'll take quiz 5 this week. You also have two other tasks besides the quiz. You have a reflection number 2. This reflection topic, if you recall from the first week of class, we did a reflection activity that you submitted, and then respond to others. This reflection is on the ACL injury in female athletes, a very common injury in the knee due to the structure of the cruciate ligaments and lateral cruciate ligaments, and potential injuries that arise and that we see quite often, predominantly in female athletes, even in non-contact, because of either improper form, muscular imbalances, weakness of the hamstrings, weakness in the knee and the hips. So a lot of things that can go on there. I'll let you explore that topic and decide for yourself what you think is the leading cause and how we can prevent that. So that's in the reflection. And then you have muscle chart number 4, which is on, of course, the knee, ankle, and foot, for the muscles that attach to all the bony structures that we looked at early on. Okay, so for the PowerPoint content, the PowerPoint starts off for chapter 9 just isolating the knee, and then chapter 10 PowerPoint goes into the foot and ankle. For the knee, the big thing that we're looking at is the knee joint, obviously. There are actually multiple joints within the knee, technically, because it is very complex. It's a large hinge joint, but there are technically 4 bones that are coming together. So you have your femur. The distal end of the femur is where the condyloids are. The epicondyloid surface is meeting with the top of the tibia, which creates the hinge joint. And then you have the patella bone that's sitting right on top of where the femur and the tibia come together. Then you also have the fibula on the lateral aspect that's meeting up at the lateral side of the tibia, just below the lateral epicondyle of the femur as well. So very complex, a lot going on there. The big thing is that yes, it's a diarthrodial joint, it's freely movable, but it primarily just flexes and extends. That's our primary action. There's a little give and take, obviously. You can bend the knee, twist the knee a little bit, but we have these ligaments, often referred to as like the ACL, MCL, LCL. Those are the popular ones, the PCL. ACL is the most common ligament that's referred to because that is the one that's really keeping the femur in line on the tibia and basically stopping you from displacing the femur, those lateral and medial epicondyles off of the head of the tibia. So it's help keeping it in place. But if there's enough pressure, enough force, like anything, those ligaments can tear, and which is very common in some cases. So take some time, go through and look at the structure of each. You should be able to take an image of a knee and identify, the difference between the LCL, the MCL. LCL being lateral cruciate ligament, MCL being on the medial side, and then be able to identify the ACL and PCL and MCL, and then also take a look at the menisci. Meniscus is like I think of it like two donuts that sit side by side. It almost looks like an infinity sign that allows the epicondyles of the femur to sit on the tibia. So a very unique structure with all those ligaments and tendons that connect in there. Because you also have the patella tendon that's going over and through the patella, the kneecap itself, connecting to the tibial tuberosity on the front of the tibia, and then up into the quadriceps. So all of these ligaments and tendons are working together to keep the knee structure in one piece and allow you to move functionally and also absorb forces and so forth. So the bones that you're going to be looking at, take a close look at the femur, the condyles of the femur. Take a look at the medial aspect of the tibia, and then the fibula as well. Those are our three bones, and then the fourth one would be the patella, the kneecap, which is its own bone. It's a what we call a sesamoid bone or a floating bone. Okay, check out the landmarks, like I mentioned, tibial tuberosity. That should be a number one landmark that you find on the tibia, because that's where the patella tendon connects. So there's some landmarks to look at, and then with the bones, it talks about which muscles connect to the bones. It goes into the joint. The big joint we're looking at is the tibiofemoral joint, is the technical name for the pivot joint between the tibia and the femur. And then we also have the patellofemoral joint, which is where the patella sits over the femur, which is more of a gliding joint. Okay. Then it gets into talking about how the menisci function to cushion the bones and so forth. And then once you get through all the joint content, which there's a lot in there, there's also some content on the role of bursae, bursa sacs, which are really important in the knee. Talks about range of motion. And then it talks about movements. So we're getting into movements. The primary movements are flexion and extension of the knee. Extension is controlled by and activated by the quadriceps primarily. So the vasti muscles, vasti lateralis, medialis, intermedius, and the rectus femoris. And then flexion is activated and controlled by the hamstrings. So the biceps femoris, the big one, and then the semitendinosus and membranosus. Okay. So take a look at those muscles. It breaks down all four quadriceps, where they're located, and then as well as the hamstrings. Okay. Other muscles that are discussed: gracilis, the sartorius. Those are, and as well as the lateral head of the gastrocnemius is discussed, since it does connect to the back of the knee. Okay. So those are the big ones to look at. Another muscle that's thrown in there on the posterior aspect is the popliteus. A little muscle that helps basically unlock the knee. And then it goes into nerves. Okay, a couple nerves that come down the leg. You have the femoral nerve, and then you have the sciatic nerve on the backside, going down to the tibia. Okay. All right. The rest are just some resources and discussing the role of muscles and so forth in the knee. And then it goes on to the ankle. Ankle is looking more at, how the distal aspect of the tibia sits on top of the talus, that then sits on top of the calcaneus. Talks about the calcaneal bone, where your Achilles tendon connects, which goes into the sheath of the gastrocnemius and soleus, which we call the gastroc-soleus complex. Talks about the role of plantar flexion versus dorsiflexion as our actions. We also have supination and pronation. The ankle gets a little complex. There's a lot of bones in the foot and ankle, and there's a lot of movement going on. And often the movement is in two different planes at the same time, which is where we get our pronation and supination. That's where you're combining like eversion or inversion, along with dorsiflexion and plantar flexion. So it gets a little complicated. So spend some time looking through the ankle, looking through the bones in the foot, all the tarsals, metatarsals, and then the phalanges, of course. And then once you get familiar with the content in the PowerPoints and the textbook, take some time and start filling out the muscle charts that are located on Blackboard. Once you get those completed, you can submit them online, and I'll review them, and then get right into the reflection question, and then take your quiz for the week. That's about all we have. There's a lot of content to go through, so make sure you're working through this diligently, and then we'll get on to the trunk and spinal column next. All right. As always, if you have questions, let me know. See ya.